In this lecture, we're going to solve problems on the discrete time Fourier transform, right? So before we solve problem, so we have to summarize the basic signal Fourier transform. So I'll summarize basic discrete time Fourier transform pairs. That is, so in the left side, these are the signals. In the right side, these are the Fourier transform. So what my suggestion is, so you have to write these signals as well as the corresponding Fourier transform, paste it in your reading room, right? Now the first signal is anyway a power n u of n, where mod a less than 1. So this a should be less than 1, then only it will be absolutely summable, then it will have Fourier transform. So the Fourier transform is 1 by 1 minus a into e power minus j omega. So a can be positive, a can be negative, but it should be less than 1. Similarly, a power mod n and a should be less than 1. So mod n, so this function also we have done, that is we will get 1 minus a square by 1 minus 2a cos omega plus a square. Now what is the Fourier transform del function? Is always 1. Similarly, delta n minus n, that is a time shifting property. Simply delta n means 1, shifting is there, so e power minus j omega into n naught. Similarly, what is the Fourier transform of int step sequence? So this is 1 by 1 minus e power minus j omega, because a power n u of n. So a is 1, so 1 by 1 minus e power minus j omega plus, if I integrate del function, we'll get u of n. So that's why it will become 1 by 1 minus e power minus j omega plus it should be pi of del omega into x of e power j0. Anyway, e power j0 means 1 only. So pi into, but this should be in periodic. So that's why sigma k is equal to minus infinity to infinity del omega minus 2 pi k. Okay, that is about the unit step sequence. The next one is the periodic signal, that is e power j omega naught n. So what was the Fourier transform? 2 pi L is equal to minus infinity to infinity. There is a shifting, that is here plus omega naught, will get minus omega naught, but it should be periodic, so that's why minus 2 pi L. And what is the period is 2 pi. Now once we find the harmonically related exponentials, so this is also a periodic signal, but it is harmonically related frequencies. So we'll get the Fourier transform as in terms of Fourier series coefficients, that is 2 pi sigma k is equal to minus infinity to infinity ak del omega minus 2 pi by n into k. So here we'll get positive, then we get shifting is negative. So sometimes this 2 pi by n will be replaced by omega naught also. Similarly, cos omega naught, sin omega naught. So for cos omega naught, we'll get pi into L sigma L is equal to minus infinity to infinity. Here we'll get e power j omega naught. So we'll get minus, that is omega minus omega naught minus 2 pi L. Next one is minus j omega naught. So it will become del omega plus omega naught minus 2 pi L. For sin omega naught, so pi will be replaced by pi by j, because this will be replaced by e power j omega naught n minus e power minus j omega naught n by 2j. So j will come here, and in this inside will get minus, but both are same. Next one is in time domain, there is a constant for all n, which is periodic. It may be periodic, it may be not periodic in our time domain, but it should be periodic in the frequency domain. So it should be 2 pi del omega, but should be periodic, that's why del of omega minus 2 pi L, where L is minus infinity to infinity. The last signal is the rectangular signal in the time domain, that is 1 for mod n less than or equal to n1. So in the frequency domain, this will become sine of omega into n1 plus half by sine omega by 2. Remember this one, this 11th one is very, very important, right? So when a rectangular signal is there and the n1 is there, suppose 2 or 3 or 4 etc. So we have to find the Fourier transform like this, right? The difference equations, that is this difference equation is given. So what we need to find, determine the frequency response of the system and determine the impulse response. So frequency response means always h of e power j omega. If I find the inverse Fourier transform of this frequency response, we will get impulse response. Now from the equation, so if I convert into Fourier transform, so y of n means y of e power j omega minus 1 by 6 y of n minus 1, that is shifting. So you will get e power minus j omega y of e power j omega. Next one is minus 1 by 6 y of n minus 2. So shifting is by 2 j omega 2 y of e power j omega is equal to x of n will become x of e power j omega. Now if I take y of e power j omega common, so from this we'll get 1 minus 1 by 6 into e power minus j omega minus 1 by 6 minus e power minus j omega 2 is equal to x of e power j omega. So what we need, frequency response. So frequency response is equal to h of e power j omega, which is output Fourier transform by input Fourier transform. This will become 1 by 1 minus 1 by 6 e power minus j omega minus 1 by 6 e power minus j omega 2. So this is the frequency response. That is the part A. Now in the part B we need to find the impulse response. That is, we need to find the inverse Fourier transform for this one. So if I take here h of e power j omega is equal to 1 by 1 minus 1 by 6 e power minus j omega minus 1 by 6 e power minus j omega. Now to solve this type of problems, we remember always we need to take this it's a quadratic expression looking like, so we need to find the factors, right? Now how to find those factors? So by seeing this one we may think it's somewhat difficult. Now to avoid this difficulty, what we'll do is let x is equal to e power minus j omega, right? So what it will become, 1 by 1 minus 1 by 6 e power minus j omega replaced by x, and it will become x square by 6. And if I take LCM 6 common, so it will be 6 by 6 minus x square. Now we can now easily solve this one. How? 6 by minus x square minus x plus 6. Now that is, if I multiply I should get minus 6, and if I add we'll get minus x. So that will become 6 by minus x plus 2 into x plus 3. So what we will get? See here, minus x into x minus x square minus x into 3 minus 3x plus 2 into x 2x plus 2 into 3 6. So whatever we'll get, this is the same. So but what is x here? So again we have to replace by 2 minus e power minus j omega into x means again 3 plus e power minus j omega. Again, so it should be in the form of 1 minus a into e power minus j omega. So we have to bring like that. So if I take 2 common here, so it will become 1 by 6 by 2 common, 1 minus 1 by 2 e power minus j omega. Similarly, if I take 3 common, it will become 1 plus 1 by 3 e power minus j omega. So 6 by 2 into 3 will be cancelled. Now the equation now is very simple. H of e power j omega will be simply 1 by 1 minus 1 by 2 e power minus j omega into 1 plus 1 by 3 e power minus j omega. Now just we need partial fractions, that is a by 1 minus 1 by 2 e power minus j omega plus b by 1 plus 1 by 3 e power minus j omega. That is a partial fraction. Now to find a, what we need to substitute, e power minus j omega is equal to 2, right? 1 minus 1 by 2 into e power minus j omega equal to 0. So e power minus j omega will become 2. So in what equation we have to substitute this equation, but this should not come. So 1 by 1 plus 1 by 3 into e power minus j omega is 2. So this is 2. So this is 2 by 3. So 1 plus 2 by 3 means, so we'll get 3 by 5. Similarly, to find b, e power minus j omega will become, see here, 1 plus 1 by 3, so it will become minus 3. So the expression is 1 by 1 minus 1 by 2 into minus 3. So again you will get minus minus cancel, so it will become 2 by 5. So a is 3 by 5, b is 2 by 5. Now what is the inverse Fourier transform of this signal? So 1 by 1 minus a into e power minus j omega, 1 by 1 plus a into e power minus j omega. So So this will become like this. So I'll write here h of e power j omega is equal to 3 by 5 1 minus 1 by 2 e power minus j omega plus 2 by 5 1 plus 1 by 3 e power minus j omega. Right? Now we know that a power n u of n is the Fourier transform is 1 by 1 minus a into e power minus j omega. If you see for the first one it's matching. So what is the h of n? 3 by 5 into 1 by 2 power n u of n plus the second function is 2 by 5, but in place of minus we are getting plus, so that means a should be negative. So what is the negative value? Minus 1 by 3 power n u of n. So this is the inverse Fourier transform of the given difference equation. So always remember, any difference equation given, always we need to try to bring in form of 1 minus a into e power minus j omega, right? A causal unstable LTI system has the property that 4 by 4 n e of n, if I apply to the system, we will get output as n into 4 by 5 n power n e of n. Determine the h of e power j omega, that is frequency response, and determine the difference equation relating input x of n and corresponding y of n. Right? See, this is x of n is given, this is y of n is given. Now to find the h of e power j omega, it's very easy. Now to find a, so what is x of n? It is 4 by 5 power n e of n, and y of n is given n into 4 by 5 power n u of n. Now what is the Fourier transform of this signal? Simply 1 by 1 minus 4 by 5 e power minus j omega. But to find the Fourier transform of this one, so there is a n. So we know already this Fourier transform of this signal. So the overall Fourier transform of this signal is n, means in the frequency domain we will get d by d omega of 1 by 1 minus 4 by 5 e power minus j omega. Now how to differentiate? J into, it is looking like 1 by x. So 1 by x means minus 1 by x square, that is 4 by 5 e power minus j omega whole square. But I assume this is x, so we need to differentiate in the numerator. So it will become minus 4 by 5 into e power x, means e power x into, I need to differentiate this one, so we'll get minus j. So minus minus minus, again you will get minus j into j square minus, so it will be plus. So what is the overall will be 4 by 5 e power minus j omega by 1 minus 4 by 5 e power minus j omega whole square. This is y of e power j omega, and this one is x of e power j omega. Now we know how to find h of e power j omega, that is output response by input response. Now what is the Fourier transform or frequency response is h of e power j omega is equal to y of e power j omega by x of e power j omega. So what is y of e power j omega? 4 by 5 e power minus j omega by 1 minus 4 by 5 e power minus j omega whole square by 1 by 1 minus 4 by 5 e power minus j omega. So this will be, one time will be cancelled. So what we will get? Simply h of e power j omega is equal to 4 by 5 e power minus j omega by 1 minus 4 by 5 e power minus j omega. Next, this is the frequency response. Now to find the relation between input and output with respect to difference equation, so again this will become e power j omega by x of e power j omega, which is 4 by 5 e power minus j omega by 1 minus 4 by 5 e power minus j omega. Now we have to just cross multiply like this. So it will become y of e power j omega minus 4 by 5 e power minus j omega into y of e power j omega is equal to simply 4 by 5 e power minus j omega into x of e power j omega. Now if I take the inverse Fourier transform. So y of e power j omega will become y of n minus constant is constant only. Y of e power j omega is y of n, but there is a e power minus j omega n, and that is shifting. So one time. So y of n minus 1 is equal to 4 by 5 x of n, but there is a e power minus j omega n naught, so it will be n minus 1. So this is the difference equation. Once we know h of e power j omega, the difference equation is very easy to find. Just cross multiply, then take the inverse Fourier transform. Right? One more question, and this is from the LTI system, the interconnection of the LTI system. In LTI system with impulse response, h1 of n is equal to 1 by 3 power n u of n is connected in parallel with another causal LTI system with h2 of n. h1 of n connected parallel with h2 of n. The resulting parallel common interconnection has the frequency response. The total frequency response is given. Now we need to find h2 of n. Now we know that parallel combination means, so h1 of n and parallelly h2 of n, and there is a sigma. So this is the parallel interconnection, that is h1 of n and h2 of n is connected in parallel interconnection. Right? Now if we want to find the overall impulse response, it is nothing but we already discussed. H of n is equal to h1 of n plus h2 of n. Right? Now if I take the Fourier transform, this will become h of e power j omega is equal to h1 of e power j omega plus h2 of e power j omega. Now h of e power j omega is given and h1 of n is given. Now we know h1 of n is equal to 1 by 3 power n u of n. Right? So what is the Fourier transform of this function? We know a power n, that is 1 by 1 minus a, 1 by 3 into e power minus j omega. Now we have to substitute h1 of e power j omega, h of e power j omega to find h2 of n. Now how to solve this one is, so h of e power j omega, that is minus 12 plus 5 e power minus j omega by 12 minus 7 e power minus j omega plus e power minus j2 omega is equal to h1 of e power j omega, that is 1 minus 1 by 3 e power minus j omega plus h2 of e power j omega. Now if you see this one, this is going this side, but first we need to find the partial fraction of this function. So how to do the partial fraction? We discussed this one in the previous example. So we need to find, let x is equal to e power minus j omega. So that will become minus 2 plus 5x by 12 minus 7x plus x square. So this will become x square minus 7x plus 12. That means this can be easily written minus 12 plus 5x by x. See, we should get minus 7, right? So if it is written like this, x of 4 3's, so x minus 4 into x minus 3. So x square minus 3x minus 4x minus 7x minus 4 into minus 3 plus 12. So how to find the partial fraction? Now we will find, again replace x is equal to e power minus j omega. So minus 12 plus pi e power minus j omega by e power minus j omega minus 4 into e power minus j omega minus 3. Right? Now, but we don't require in this form, we require 1 minus a minus j omega, etc. So what we do, we'll take minus 4 common. Right? Here also minus 3 common. So what it will become? Minus 12 plus pi e power minus j omega by, so minus 4 common means 1 minus 1 by 4 e power minus j omega into minus 3 common, so 1 minus 1 by 3 e power minus j omega. Right? So minus minus will be cancelled, 12. So the final you can write minus 12 plus pi e power minus j omega by 1 minus 1 by 3 e power minus j omega into 1 minus 1 by 4 e power minus j omega is equal to 1 minus 1 by 3 e power minus j omega plus h2 of e power j omega. Again we need to find the partial fraction of this function, right? So how to find those partial fractions? So a by 1 minus 1 by 3 e power minus j omega plus b by 1 minus 1 by 4 e power minus j omega. So what is a? A is equal to minus 12 plus 5 e power minus j omega by 1 minus 1 by 4 e power minus j omega. Here we shall have to substitute e power minus j omega equal to 3, because we are finding a in the a denominator. We are having 1 minus 1 by 3 e power minus j omega. So if I make it is equal to 0, e power minus j omega equal to 3. What is the value we will get? Minus 12 plus 5 into 3 by 1 minus 3 by 4. So 15 minus 12 is 3. So what is this? 1 minus 3 by 4. So it will come 1 minute minus 12. Yeah, here I forgot to write 12 here, right? So it will become 12 also into 12. So this will become 12 into, so 1 minus 3 by 4, so it's 1 by 4. So 4 3s, 3 3s. So what is this? A is equal to simply 1, right? So here I forgot to write 12 here because we are having 4 into 3 12, right? So that's why we'll get A is equal to 1. Similarly, we find B. B is equal to minus 12 plus 5 e power minus j omega by 1 minus 1 by 3 e power minus j omega, where e power minus j omega equal to 4. Same, minus 12 plus 5 into 4 by 12 into 1 minus 1 by 3 into 4. So what will get? Minus 12 plus 20. So 8 by 12 into 1 minus 4 by 3. So what will get? Minus 1 by 3. So 3 4s and 4 2s. So what is B? B is equal to minus 2. So the final expression will get 1 by 1 minus 1 by 3 for minus j omega minus 2 by 1 minus 1 by 4 e for minus j omega is equal to 1 by 1 minus 1 by 3 for minus j omega plus h2 of e power j omega. We see we can cancel these two, and h2 of e power j omega will become minus 2 by 1 minus 1 by 4 e power minus j omega. Now if we take this Fourier transform, inverse Fourier transform, so this will become h2 of n. Now what is this inverse Fourier transform? We know if it is 1 by 1 minus a e power minus j omega, it will be 1 by 4 power n u of n. So minus 2 into 1 by 4 power n u of n is the h2 of n. So this is how we have to do this problem. I of n is given something like this. From 0 to 4 there is a amplitude is 1, the impulses. Then we have to find the Fourier transform of some different signal x of n, which is depending on this y of n, that is y2 of n and 2 into y2 of n minus 1. In this problem we have to apply this time expansion property, time shifting property. For this signal also we need to apply the time shifting property. So clearly observe. Now first, what is y of n? So y of n is this one, but if we know, we have discussed the one rectangular pulse, that is from minus n1 to n1, some signal suppose is there, some g of n, right? Now what is the Fourier transform of this signal? So in the table also we discussed any rectangular function, it can be represented by Fourier transform sine omega into n1 plus half by sine omega by 2, right? Now see here, if you clearly observe, so if I shift left shift, that is minus 2 2, that is n plus 2, so this will become minus 2 and this will become plus 2. So that means this should be minus 2 to 2, because it will have 4 impulses. So minus 2 means 1, then minus 1, then 0 1 2. See, 1 2 3 4 5, 1 2 3 4 5. So that's why we have to think like this. First, the rectangular function we have to take, and what is the Fourier transform? Now n is equal to n1 is equal to 2. So the Fourier transform for this one sine omega into n1 is 2, so 2 plus 1 by 2 by sine omega by 2. That is, I will write as g of e power j omega is equal to sine 2 plus 1 by 2, so 2.5, so I can write 5 omega by 2 by sine omega by 2. So first part is over. Now we require y of n first, then we can find y2 of n, 2 into y2 of n minus 1. But what is the relation between this g of n and y of n? Y of n is equal to, I can replace g of n minus 2. Suppose if I shift this towards the right side by 2 times, so minus 2 plus 2 it will become 0, minus 1 plus 2 it will become 1, 0 plus 2 2, 1 plus 2 3, 2 plus 2 4, you will get same as this one. So now we know from the shifting property y of e power j omega is equal to simply e power minus j omega 2 into g of e power j omega. Now say we'll get into e power minus j omega by 2. So what we'll get? Y of e power j omega is equal to e power minus j omega 2 into sine 5 omega by 2 by sine omega by 2. This is y of e power j omega. Now what we require? We require x of n, which is y2 of n plus y2 of n minus 1. Now if I find the Fourier transform, this will become x of e power j omega. So y2 of n means, so it's a time expansion. We know that it will be, I will write as y2 of e power j omega only. This one also, this is a shifting, right? So we'll get e power minus j omega into y2 of e power j omega. Now first we have to find y2 of e power j omega, then it's very easy. Now we know that y2 of e power j omega means, so any scaling factors I will recall. So y2 of n means in the Fourier transform it will become y of e power j omega k, right? What is k here? 2. So it will become y of e power j omega 2. That is, in place of omega we have to substitute omega 2. So that means, so we know this is y of e power j omega. Then y2 of e power j omega will become, we have to substitute omega 2. That is e power minus j omega 2 into 2 sine 5 into omega 2 by 2 by sine 2 omega by 2. So 2 cancel. So what is the resultant? E power minus j 4 omega into sine 5 omega by sine omega. This is the y2 of e power j omega. Once we know this y2 of e power j omega, just we need to substitute here. So this will become x of e power j omega is equal to y2 of e power j omega. So what we got? E power minus j 4 omega into sine 5 omega by sine omega plus e power minus j omega into y2 of e power j omega. So it will become e power minus j 4 omega into sine 5 omega by sine omega, right? Now if I take e power minus j 4 omega common, e power minus j 4 omega common, and these two also common, sine 5 omega by sine omega. So what is this? We'll get, the total is common, so 1 plus e power minus j omega. So this is x of e power j omega, right? So this is how to find some different signals somehow given. So what is the properties we need to apply, that we have to decide first, right, from the given signal, right? Next we will see this problem, that is x of e power j omega is given, so we need to find the inverse Fourier transform, that is x of n we need. Right, to solve this one again we need to go for the partial fractions, but so we may some complexity you may see here, but what we need to do is just very simple. So take the denominator, 1 minus 1 by 4 e power minus j omega minus 1 by 8 e power minus j 2 omega. To make factors by these fractions, so it's somewhat difficult. What we do, make it as LCM, so this will become 8 minus 2 e power minus j omega minus e power minus j 2 omega by 8, right? So the numerator, so it will become minus x square minus 2x plus 8 by 8, right? Now it's very easy. So if I multiply, I should get minus 8. If I add, I should get minus 2. So what we can assume, so minus x square minus 4x plus 2x plus 8. So see, minus 4 plus 2x will become minus 2 only. It is plus. So if I take minus x common, this is by 8, then it will become x minus 2 from these two. And from these two, if I take minus 4 common, this will become x minus 2. So by 8. So what are the factors? Minus x minus 4, x minus 2 by 8. Yes or no? Now if I multiply also, we'll get the same expression. So now take 4 common, minus 4 common. So minus 4 if I take common, so it will become 1 plus x by 4 into, if I take minus 2 common here, minus 2, so it will become 1 minus 1 by 2 x, right? So minus 2 minus 2 8, so it will be 8, it will be cancelled. So this denominator expression, simply it will become 1 minus 1 by 3 for minus j omega by 1 plus x by 4. That means 1 plus 1 by 4 into e power minus j omega into 1 minus 1 by 2 e power minus j omega. Even if you multiply also, we will get the same. See, 1 into 1, 1. 1 into minus 1 by 2 plus 1 by 4 e power minus j omega. So minus 1 by 2 plus 1 by 4, we will get minus 1 by 4. 1 by 4 into 1 by 2, 1 by 8, minus is there. So we will get same expression. Now it's very simple now to make partial fractions. 1 by 4 e power minus j omega plus b by 1 minus 1 by 2 e power minus j omega. This is x of e power j omega. Now to find a value, so we have to substitute. So this is the denominator. So e power minus j omega is equal to minus 4. We need to substitute. So that is 1 by 1 minus 1 by 3 e power minus j omega by this 1 minus 1 by 2 e power minus j omega. Now at e power minus j omega equal to minus 4. So if I substitute 1 minus 1 by 3 minus 4 by 1 minus 1 by 2 into minus 4. Right, so minus minus cancel, 2 2's. So this is 7 by 3 by 3. It is 7 by 9. Similarly, we can find b is equal to, that is e power minus j omega is equal to 2. That is 1 minus 1 by 3. I directly substitute. This is 2 by 1 plus 1 by 4 into 2. So 2 2's. So this will become 1 minus 2 by 3. That is 1 by 3 by, so this is 1 plus 3. So 1 plus 1 by 2, sorry, 1 plus 1 by 2. So 1 by 3 by 3 by 2. So what is this? Simply 2 by 9. So a is 7 by 9, 2 by b is 2 by 9. So if I substitute here, so we'll get 7 by 9 by 1 plus 1 by 4 e power minus j omega plus 2 by 9 by 1 minus 1 by 2 e power minus j omega. So this is x of e power j omega. Now it is simply in the form of 1 by 1 minus a into e power minus j omega. So we take the inverse Fourier transform, it will become x of n, which is equal to 7 by 9. 1 by 1 minus a, it is plus, so minus of minus a we can write. That will become minus 1 by 4 power n u of n plus here 2 by 9 into, it is simply same form, that is 1 minus a into e power minus j omega. So a power n u of n, right? So this is this inverse Fourier transform. Now in the next lecture we will solve some gate questions, the previous gate questions in the next lecture, right?